So good morning, everyone. We'll continue with the Big M method because there are two different types are there still remaining in the method. So we'll continue with the Big M method. We have done two problems on that day. So we'll just continue with that. Take the next problem. So what is the difference between the simplex method and the Big M method? What is the difference between the simplex method and the Big M method? In the simplex method, objective function is maximization. All the constraints are less than or equal to, and right-hand side is non-negative. In Big M method, also objective function is maximization, but there is no restriction on the constraints. You can have equal to constraint, you can have greater than or equal to, or you can have less than or equal to. But right-hand side is again positive for both the methods. So now in this problem, we have to solve by Big M method because we are having greater than or equal to constraint. It cannot be solved by simplex method because even if you try to convert this inequality, the right-hand side will become negative. Right-hand side has to be positive for applying simplex method or Big M method. So first step will be, we have to check the objective function. So objective function is maximization. So we can apply Big M method. The constraint. The first constraint is greater than or equal to 8. Since we have greater than or equal to constraint, which means that the left-hand side is greater than the right-hand side. So you have to subtract something from the left-hand side so that both the sides are equal. And that the variable which we subtract from the greater than or equal to constraint is called as a surplus variable. So here we have to subtract a surplus variable. Here we have to add a slack variable because we have less than or equal to. And I told you in Big M method, whenever you are having a greater than or equal to constraint or an equal to constraint, we should add an artificial variable. Why we are adding artificial variable? Just to get that unit matrix in the table, 1 0 0 0 1 0, whatever is the order of that unit matrix. So in the Big M method, artificial variables are added to greater than or equal to constraint and equal to constraint. So here we have one greater than or equal to constraint. So we have to add one artificial variable. So we'll add that. All these things. So first constraint may we have to subtract a surplus variable and add an artificial variable. So that equal to ho jata hai. Second constraint may we have to add only slack variable. So let the slack variable be equal to S2. And then the objective function, we give the cost to these slack and surplus variable as 0 and 0. And the cost of the artificial variable is given as minus m in the case of maximization problem. Okay, so we are giving the cost as minus m to the maximization to the artificial variable in the maximization problem, which means that, and we know that the value of m is very large. Okay, that is why this Big M method is called. So now we have to write all these things in the table, solve for that, and get the solutions for that. So first step is, now here we have only one constraint of this part. So we have to add one artificial variable and give the cost as minus m. So I'll rewrite this in the next slide. Okay. So first step, same table, whatever we have done in the previous lecture or for simplex method, the same table we have to follow here also. So again, writing all the variables here, x1, x2, x3, s1, a and S2, and the right hand sides are denoted by BI. So writing the coefficients of all the variables from the first constraint. Again, I am repeating, these two are called as the constraint. This is not constraint, this is called as non-negativity constraint. Constraints are only these two. So writing the coefficients of all these variables in the as the first row. So first we will have 3. Coefficient of x2 in the first constraint is 4, फिर 2, s1 minus 1 है, sa is 1, S2 is not there in the first constraint, so 0, right hand side is equal to B. Okay, please do it along with me so that we can confirm our answers also. उसके बाद सेकेंड कंस्ट्रेंट लेना है, कोएफिशिएंट ऑफ x1 2 है, कोएफिशिएंट ऑफ x2 1 है, x3 1 है, s1 is not there in the second constraint, तो 0, a भी नहीं है 0, s2 का 1 and bi is equal to 2. So writing the coefficients of all the variables from these two constraints. Since there are two constraints, we will have two rows. After writing all the coefficients of all the constraints, next we have to write the coefficients of all the variables from the objective function, and that we denoted by Cj. Cj's are the cost of the variables x1, x2, etc. तो यहाँ पे आ जाएगा 3, फिर 2, फिर 3, फिर 0, a का minus m और s2 का 0. So always we give the cost as 0, 0 to slack and surplus variable. Only the artificial variable is having the cost as minus m. उसके बाद we have to write this xb column. Now tell me which variables are there in the xb column. Which variables are there in the xb column? बताओ कौन कौन से variables होंगे? A and
S2.
Now I can see both the chats because I've logged into two different devices, so don't bother about that. Even if you don't unmute, it's okay. ठीक है, लिख सकते हो chat box में, या अगर unmute करना है तो कर भी सकते हैं. तो कौन कौन से variables है? Now there are two constraints, so we will have only two, that is unit matrix of order 2. So 1 0 is corresponding to A and this is S2. ठीक है, A and S2. Yes. S2 हो गया. नेक्स्ट हमको क्या लिखना है? CB. CB का मतलब होता है कॉस्ट ऑफ दीज वेरिएबल्स. कॉस्ट ऑफ A हमने लिया है -m, तो यहाँ -m आ जाएगा. कॉस्ट ऑफ S2 वी हैव टेकन एज 0, तो यहाँ पे 0 हो जाएगा. उसके बाद हमको लिखना है ZJ. ZJ कैसे निकालते हैं? -m into 3 plus 0 into 2. For the first column, it is -m into 3, 0 into 2. That will become -3m. Second column के लिए -m into 4 plus 0 into 1. So -4m. -m into 2 plus 0 into 1. -2m. -m into -1, that is m. This is -m. यहाँ पे 0. That's it. In some books, you'll find even this part written. I'm not doing that part. I'll calculate only in the end. अगर हमने ये भी part कर दिया, we will get the value of z actually. मैं नहीं करती because why to increase one more row transform, मतलब one more calculation. So I'm avoiding that. In the last step, I normally calculate the value of z from the z function. Okay. Now next row is zj minus cj. So zj minus cj is -3m -3. Second column में -4m -2, -2m -3, m -0. -m plus m 0, 0 minus 0 0. नॉर्मल बेसिक टेबल है, जब हम लोग सिंप्लेक्स में यूज करते हैं, बिग एम मेथड भी वो यूज होता है, एक्सेप्ट फॉर दिस आर्टिफिशियल वेरिएबल एक्स्ट्रा पार्ट. ओके, नाउ टेल मी विच इज द की कॉलम. Which one is the key column?
-4m -2.
-4m -2. Why? Because m is very large. अगर मैंने m की वैल्यू 100 ले ली तो यहाँ पे आ जाएगा -300 -3 which is -303. यहाँ पे आ जाएगा -402. यहाँ पे आ जाएगा -203. तो बिना माइनस साइन के जो भी नंबर बड़ा है, that is called as the most negative number. So it is -4m -2, which means that this second column is the key column. Okay. After calculating the key column, we have to take the ratio. And the ratios are, so see the elements in the key column. ये दो constraint के दो elements हैं. So we have only 4 and 1. So both are positive. So we can take the ratio. If you have negative or 0, we should not consider for ratio. So ratios are taken only for the positive numbers in the key column, not for negative or 0. So taking the ratio here, 8 by 4, that is 2. 2 by 1 is also equal to 2. So that is why I told this is a different problem, because we have similar ratios here. Actually, we have to choose the minimum ratio, but here we are having both the values are same. So in such cases, you can take any one of them as the key row. Any one row you can take it as key row. It is your luck that you may get more number of iterations, or you may get less number of these tables. Okay, so any one you can take. But so what I'm doing is, because we have this element as 1, I'm considering this as the key row. ओके, मैं ये ले रही हूँ. द रीजन इज हमको डिवाइड करके इसको 1 करने की जरूरत नहीं पड़ेगी. यहाँ पे अगर इसको मैंने चूज किया तो फिर हमको इसको डिवाइड करके 4 से डिवाइड करना पड़ेगा. तो ये 1/4 यहाँ पे सब फ्रैक्शंस में आ जाएंगे. जस्ट टू अवॉइड दैट, बिकॉज ये नंबर 1 है, तो मैंने इसको की एलिमेंट ले लिया है. You can also take this element as the key element, nothing wrong in that. Answers will be the same. Okay, so when you have two similar minimum ratios, you can choose any one of them to be the key row. I have taken this as the key row because the key element will become 1 if I take this row. If I choose this row as the key row, then the key element will be equal to 4. Then you have to make the key element equal to 1 by dividing the first row by 4. So we will have these fractions here, so we are avoiding that. तो मैंने क्या किया है, सेकेंड रो को की रो ले लिया है, और ये जो 1 है, सॉरी, ये जो 1 है, दिस बिकम्स द की एलिमेंट, है ना. So this is your key element. This part is the key element, है ना. I forgot to write that key element over there. This is the key element. Okay. So now, so अभी नेक्स्ट टेबल में हम लोग को क्या करना है, CJ वाला रो निकाल देंगे, CB वाला रो निकाल देंगे, ZJ वाला रो एंड रेशियो का जो रो है, पूरा कॉलम है, पूरा निकाल देंगे. We will have only these variables XB, X1, X2, X3, S1A, S2B and then ZJ minus CJ. तो CJ को रिमूव करेंगे, CB वाले कॉलम को रिमूव करेंगे, रेशियो वाले कॉलम को रिमूव करेंगे और ZJ वाले रो को रिमूव करेंगे. And then we will write the next table. Same thing till now, whatever we had done in the previous lecture, everything is same except for we are getting two similar minimum ratios. We are having two similar minimum ratios. So I'll move to the next part, next table. तो next table मैंने क्या किया है, ये सब निकाल दिया और उसके बाद लिख दिया है वहां पे. ठीक है, तो मैंने लिख दिया की एलिमेंट 1 था. So now key element is already equal to 1. Make the other elements in that particular column equal to 0 using this key element 1. ये 1 यूज करके हमको इसको 0 करना है और इसको 0 करना है. तो इसको 0 करने के लिए क्या ट्रांसफॉर्मेशन यूज करेंगे हम लोग, हमें R1 चेंज करना है. तो R1 कब 0 होगा, जब हम इसको 4 से मल्टीप्लाई करेंगे और सब्ट्रैक्ट करेंगे. So it will be like 4 minus 4 into R2 or R1 minus 4 into R2. And for getting this part 0, I'll take R3 plus 4m plus 2 into R2. Okay? So these are the row transformations which are required to make the X2 column as 0, 1, 0. So second रो है वो सेम रहेगा, खाली फर्स्ट रो और थर्ड रो यहाँ पे चेंज करना है. तो इफ आई एम राइटिंग R1 minus 4 R2, अगर मैंने पहला एलिमेंट लिया तो यहाँ पे R1 के बदले 3 आ जाएगा, R2 के बदले 2 आ जाएगा. सो इट विल बी लाइक 3 minus 4 into 2, वो हमको यहाँ पे लिखना है. फिर यहाँ पे आ जाएगा 4 minus 4 into 1, दैट इज 0. 2 minus 4 into, हर एक अगर हमको R1 चेंज करना है तो जितने R1 के एलिमेंट्स है उसको यहाँ पुट करना है, R2 को यहाँ पुट करना है एंड राइट दीज एलिमेंट्स ओवर हियर. सो व्हाट विल बी, आई राइट द सेकेंड रो पहले. टेल मी व्हाट इज द फर्स्ट रो. फर्स्ट एलिमेंट क्या होगा, R1 minus 4 R2. What is the first element over here? -5. Okay, -5. कैसे -5 आया, 3 minus 8. Which is -5. Okay. Second element तो 0 हो जाएगा because we're trying to make that element as 0. Third क्या आएगा, 2 minus 4. -2. Yes, 2 minus 4, that is -2. Then third ये वाला element में -1 plus minus 4 into that is minus 1 only. Next to 1 ही रहेगा. And then 0 minus 4 into 1, that is minus 4. And what will happen to BI column? BI की जगह पे क्या आएगा first row में? 0. Because it is 8 minus 4 into 2, that is equal to 0. So we have written first row. Now change the third row. Using this transformation, changing the third row. तो थर्ड रो में R3 में ये वाला पार्ट आ जाएगा, R2 में 2 आ जाएगा. So see what is the answer we get? Minus 3m minus 3 plus 4m plus 2 into 2. Open the bracket and see what remains when you simplify. Okay, Pranali is saying 5m plus 1. Okay, here Harsh also 5m plus 1. Uttara 5m. So I think it's okay, 5m plus 1. So let me check my answer. 5m plus 1. ठीक है. Second element तो 0 हो जाएगा. Third में क्या आएगा? Minus 2m minus 3. R3 के बदले minus 2m minus 3 plus 4m plus 2 into 1. What is this element? X3 column के नीचे क्या आएगा देखो. Simplify करके बताओ मुझे. 2m minus 1. Okay. Anjali, 2m minus 1, Nikita, Anushka, okay, here, Uttara, 2m minus 1, okay. So 2m minus 1. Next में क्या आएगा? S1 वाले इसमें क्या आएगा? m, because that is 0 there, so m ही आएगा. Then एक पे इसमें that is 0 and this is 4m plus 2. Is it okay? Last row, मतलब S2 वाला column जो है, 4m plus 2. ठीक है. Now tell me the variables in the XB column. Getting all of you finished with this last row? ZJ minus CJ. Okay, which variables we will get in the XB column? Always see to, again I told you also, when you have the unit matrix, it is 1 0 0 1. लेकिन जो भी unit matrix है, अभी 1 0 is corresponding to A, तो हमको A यहाँ पहले लिखना पड़ेगा, है ना? पहले A लिखना पड़ेगा, because 1 0 जहाँ पे 1 है वो वेरिएबल के ऊपर है, वो यहाँ पे देखना है. Okay, 0 1 is corresponding to x2, so we'll write x2 over here. और हमको ये भी चेक करना है कि एक के एक कॉलम के नीचे जो लास्ट रो है वो 0 होना चाहिए और x2 कॉलम के लास्ट में भी 0 होना ही चाहिए. After finishing off with the row transformation, whichever variables are there in the basis, the last row has to become 0. Okay, so we have got A and x2 and the last one is xj minus cj. अभी क्या करते हैं, कौन सा की कॉलम है? Which one is the key column now? We cannot choose the key column because there are no negative elements in Zj minus Cj. Yes, all are positive. So all these elements, Zj minus Cj's, are either positive or 0, which means that we cannot choose the key column. है ना? सब elements यहाँ पे positive है. We are not having any negative numbers to choose the key column. तो सब positive है, तो इसीलिए we will have. So we cannot proceed further with the key column and key row. So which means we have reached the final solution. Okay, we have reached the final table. Now final table में हमें क्या करना है अभी? क्या बोलते हैं, solution लिखना पड़ेगा. When we write the solution, so what are the solutions from this table actually we get? अगर मुझे solution लिखना है तो हम क्या लिख? What will be the solution from the last table? We cannot proceed further with the procedures. x2 equal to 2. Now there are two variables here, a and x2. So a equal to 0, x2 equal to 2. Okay, since we are having the solution as a equal to 0, it has a solution. अगर a की वैल्यू अदर दैन, वी हैव डन इन द लास्ट लेक्चर, इफ a की वैल्यू अदर दैन 0 है तो देयर इज नो सॉल्यूशन, we have a pseudo optimum solution. But if the value of a is equal to 0, so that our objective function will not get affected by this a, so then it has a solution. So we can write the solution zj minus cj is greater than or equal to 0, and a is there in the basis at 0 level. The value of a is equal to 0. Matlab a is there in the basis, a is there in the xb column, that is called as basis. A is there in the xb column at 0 level. The value of a is equal to 0. Therefore it has a solution. अगर यहाँ पे a की वैल्यू कुछ और होती तो then there is no feasible solution. We will have a pseudo optimum solution, which we have done in the previous lecture where we had pseudo optimum solution. तो यहाँ पे अगर a की वैल्यू 0 है तो there is no problem in that. We can choose, we can write the solutions. There are 3 variables x1, x2, x3, but यहाँ पे खाली x2 का point आया है तो x2 equal to 2, बाकी 2 variables 0 हो जाएंगे, and then we can calculate the value of z. 3x1 plus 2x2 plus 6x3 which is equal to 4. ठीक है? So ये अगर सी सपोज यू हैव टेकन द फर्स्ट रो, मैंने सेकेंड रो चूज किया था की कॉलम, तो अगर हमने फर्स्ट रो लिया होता तो ऑटोमेटिकली आर्टिफिशियल वेरिएबल कैंसिल ही हो जाता, बिकॉज दैट विल go out of the basis. So even if you choose the a part, if the value of a is 0, there is no problem. Any doubt? If the value of a is equal to 0, then it has a solution. But if the value of a is not equal to 0, then we say that it has no feasible solution or it is pseudo-optimal. तो यहाँ पे solution exist होता है and we get x1 equal to 0, x2 equal to 2, x3 equal to 0, and we write the value of z from the given objective function. क्योंकि अगर a 0 है तो whatever was the objective function maximize z, अगर a का पार्ट 0 है तो we will get only this part, क्योंकि हमने लिखा था 0s1 plus 0s2 minus ma. अगर a की वैल्यू 0 है तो we will have this only as the objective function. That is not going to affect our objective function. So we have the solution x1 0, x2 0, and x3 equal to 0. ठीक है, z is equal to 4. So 2 different cases. If the artificial variable remains in the basis at 0 level, there is a solution. If the artificial variable remains in the basis at non-zero level, it has no solution. In the basis मतलब last table में जब ये सब पॉजिटिव और जीरो हो जाता है उसके बाद चेक करना a की वैल्यू. अगर a 0 है तो सोल्यूशन है और a 0 नहीं है तो there is no solution. ठीक है? So this is the third type of problem where we have solution but still m is there in the last row. Second example where we have an equality constraint. Till now we had only inequality constraints. Now we have equality constraints. Minimize z equal to 4x1 plus x2 subject to 3x1 plus x2 equal to 3, 4x1 plus 3x2 greater than or equal to 6, x1 plus 2x2 less than or equal to 4, x1, x2 greater than or equal to 0. This was like many times repeated question in the offline exam. Almost every time they had asked this problem. I think यहाँ पे slight change होता था, लेकिन इक्वालिटी वाला एक क्वेश्चन आता ही था हमेशा एग्जाम में 8 मार्क्स के लिए. लिटिल बिट लेंथी है, थोड़े ज्यादा स्टेप्स हैं यहाँ पे, बट दे यूज्ड टू आस्क फॉर 8 मार्क्स द सेम प्रॉब्लम, इक्वालिटी कंस्ट्रेंट वाले. ओके, फर्स्ट स्टेप हमको क्या करना है, मिनिमाइज को मैक्सिमाइज करना है. उसके बाद ऑल दीज इनइक्वालिटीज आर टू बी कन्वर्टेड टू इक्वालिटी. यहाँ पे ऑलरेडी इक्वालिटी है बट वी हैव टू ऐड एन आर्टिफिशियल वेरिएबल टू इक्वालिटी कंस्ट्रेंट ऑल्सो just to get 1 0 0 unit matrix, for no other reason. Okay, we have to add this artificial variable to equality constraint as well as greater or equal to constraint just to get the unit matrix 1 0 0, because यहाँ पे 3 constraints हैं. So we should have 1 0 0 0 1 0 0 0 1. Only for that purpose we have to add an artificial variable. तो यहाँ पे दो आर्टिफिशियल वेरिएबल्स आएंगे, एक को हम a1 ले लेंगे, इसको a2 ले लेंगे, then surplus variable s1, slack variable s2. So we have a1, a2, s1 and s2. So adding these variables, तो यहाँ पे आ जाएगा a1, यहाँ पे आएगा surplus variable minus s1, फिर a2 आ जाएगा, यहाँ पे s2 आ जाएगा, and then converting minimization to maximization. Again, we don't take this minus sign into consideration while solving the problem. We take only maximization of minus z. So I'll rewrite the problem again. So what I'm doing is, since we have an equality constraint, adding an artificial variable a1. तो यहाँ पे a1 add होगा, यहाँ पे surplus variable subtract होगा, उसके साथ a2 add हो जाएगा, यहाँ पे s2, that is the slack variable, and all the variables. So I'll just write the first these constraints. ठीक है, पहले में हमने a1 add किया तो minus m a1 cost हो गया, सेकेंड में s1 सब्ट्रैक्ट किया और a2 ऐड किया तो यहाँ पे माइनस m a2, एंड थर्ड में स्लैक ऐड किया है s2, एंड ऑल दीज वेरिएबल्स आर ग्रेटर देन और इक्वल टू 0. वी हैव, तो आफ्टर कन्वर्टिंग मिनिमाइजेशन टू मैक्सिमाइजेशन ऐड दीज वेरिएबल्स. ठीक है, पहले हमको साइन चेंज करना है, उसके बाद यू ऐड स्लैक वेरिएबल एंड द कॉस्ट ऑफ आर्टिफिशियल वेरिएबल्स एक्सेट्रा, स्लैक सरप्लस जो भी हम बाद में जो एक्स्ट्रा ऐड कर रहे हैं, that has to be done only after converting the minimization problem to maximization. पहले minimize को change करके, one second, the given problem was minimization, तो पहले minimize को हमें maximize minus z लिखना है, उसके बाद add करना है artificial and all those variables. Yeah. As usual, we'll write all the details in the table. So the variables are x1, x2, s1, s2. You can go in any order, a1, a2, bi. मैंने ये order follow किया, but you can have the same order from here also. Nothing wrong in that. कोई भी order में करो, it's okay. Please write down again, because when I turn this, when I go to the next slide, I won't be able to see this one, so I can. माइनस से मल्टीप्लाई क्यों किया है, बिकॉज जो गिवन प्रॉब्लम था ना, दैट वाज मिनिमाइजेशन. गिवन प्रॉब्लम था ये मिनिमाइजेशन है. हमको जब भी बिग एम या क्या बोलते हैं सिंपलेस्ट मेथड अप्लाई करना होता है, तो वी हैव टू कन्वर्ट दिस मिनिमाइजेशन टू मैक्सिमाइजेशन. तो हम लोग उसको ऐसा लिखते हैं, बट दिस माइनस साइन वी डोंट कंसीडर फॉर सॉल्विंग द प्रॉब्लम्स. तो मैक्सिमाइजेशन ऑफ माइनस जेड हमको यहाँ से निकालना है, तो z के बदले माइनस z पुट करना है. दैट इज व्हाई वी गेट माइनस 4x1 माइनस 4x2 माइनस x2. ओके स्वस्तिक, so we'll go to the next table, writing all the variables. Again, I told you the order is not important. You can follow any orders of these variables. Now write there are 3 constraints. So we should have 3 by 3 unit matrix at the end of this table. So first we're writing the first row as the first constraint. So coefficient of x1 is 3, coefficient of x2 is 1, s1 is not there in the first constraint, so 0, s2 is also not there, a1 का 1, a2 भी नहीं है, bi is equal to 3. Writing the coefficients of all the variables from the first constraint as the first row. उसके बाद सेकेंड कंस्ट्रेंट लेना है, उसमें से भी कोएफिशिएंट्स ऑफ x1, x2 एक्सेट्रा लिखने हैं हमको. तो 4, 3, s1 is -1, s1 is -1, s2 is not there in the second constraint, a1 is also not there in the second constraint, a2 is 1, and bi is 6. Third constraint में x1 is 1, x2 is 2, s1 is not there 0, s2 के बदले 1, A1 भी नहीं है, A2 भी नहीं है, bi is equal to 4. ठीक है, नॉर्मल बेसिक टेबल व्हाट वी राइट. उसके बाद हमको लिखना है कोएफिशिएंट्स ऑफ ऑल दीज वेरिएबल्स फ्रॉम द ऑब्जेक्टिव फंक्शन. वी कैन टेक इट एज Cj. तो Cj is equal to -4, -1, 0, 0, -m and -m. After writing the coefficients of all the variables, we have to see whether we are getting, as there are 3 constraints, we should have a 3 by 3 unit matrix. So tell me which variables will be there in the xb column now. 1 0 0 से स्टार्ट करें. देखो 1 0 0 कौन से वेरिएबल के अंदर है? 1 0 0 is corresponding to 1 0 0 corresponds
A1,
to
A2, S2.
A1, then 0 1 0, A2, yes, and 0 0 1 is corresponding to S2. A1, A2, and S2, yes. Correct. Now we have to write the cost of these variables as CB. तो A1 का कॉस्ट हमने CJ में क्या लिखा है? यहाँ पे -m. A2 का भी -m. S2 का 0 लिखा है. तो we have -m and 0. Then writing ZJ. तो अभी ZJ में क्या करना होगा? ईच कॉलम के लिए हमको ZJ लिखना है. तो -m into 3 plus -m into 4 plus 0 into 1 summation CBXI. That is going to be the ZJ column. तो -m into 3 हो गया -3m, -4m plus 0. So -3m minus 4m हो गया -7m. Okay, so ZJ is -m into 3 plus -m into 4. So -3m minus 4m, that is -7m, और ये वाला पार्ट 0 हो गया तो -7m. नेक्स्ट में क्या आएगा? -m into 1 plus -m into 3 plus 0 into 2. What is that? सेकेंड x2 कॉलम के नीचे क्या आएगा? ZJ. सम करना है -4m. यस, -4m कैसे आता है? -m into -m into 1 is -m. दिस इज -3m. दोनों को ऐड किया तो -4m और ये 0. फिर यहाँ पे आ जाएगा m. -m into 0 0, -m into 0 0, 0 into 1 is 0. -m into 1 -m, this is 0, this is 0. Then 0 m -m, this is 0. Okay. Writing ZJ minus CJ. Hope it's right. The last column, last row. If there is any mistake, please let me know so that I can correct it accordingly. ZJ minus CJ निकालना है तो -7m plus 4. Then -4m plus 1. M, 0. -m plus m, 0. -m plus m, 0. Again, check whether you are having 0, 0, 0 for the variables A1, A2 and S2. A1 के नीचे 0 होना चाहिए, A2 के नीचे 0 होना चाहिए और S2 के नीचे 0 होना चाहिए. Now, the key column. So, which is the key column? Which row, which column is the key column? -7m plus 4 or -4m plus 1. दोनों में से कौन सा बड़ा है? -7m plus 4. Again, I told you, take the value as m is equal to 100 and see which is the most negative. Most negative का मतलब होता है negative sign के बिना जो भी number बड़ा है, that becomes the most negative number. So first column is the key column. Now key column, we have to see the elements in the key column. If there are positive numbers, consider those numbers for the ratio, otherwise don't consider. So here all the 3 are positive. We can take the ratios of all the 3. So bi upon 3. So 3 upon 3, that is 1. 6 upon 4, 1.5. and 4 upon 1. That is equal to 4. Now the key row. Minimum ratio is considered as the key row. So minimum ratio 1 में आता है. 1 is the minimum number. So ratio that is corresponding to the first row. So the first row becomes the key row. The intersection of key row and key column is called as the key element. Intersection of key column and the key row is called as the key element. So we have 3 as the key element. Once you get the key element, we have to make the key element 1 by dividing that particular row by the key element. Since 3 is the key element, you have to divide the first row by 3. क्योंकि हमारा key row first row है, तो we have to divide key element first row में है, तो first row को पूरे key element से divide करना है. तो dividing each element by 3. 3 by 3 will become 1, 1 by 3, 0, 0, 1 by 3, 0 and 1. So in the next table, I am not writing CJ, I am not writing CB column, ZJ also and ratio also. और फिर मैंने 3 से डिवाइड भी किया है, उसके बाद मैंने नेक्स्ट टेबल लिखा हुआ. ओके, सो नेक्स्ट टेबल मैंने क्या किया है, CJ निकाल दिया है, CB निकाल दिया है, ZJ ऑल्सो एंड रेशियो ऑल्सो. उसके बाद 3 से डिवाइड भी करके मैंने लिखा हुआ है. ओके, तो जस्ट चेक, आई एम गोइंग टू द नेक्स्ट स्लाइड. So what I have done is I've divided that row, ठीक है, by 1 by 3, sorry, by 3. So this is a key element, I think, है ना? This was the key element. Okay, now if you see this artificial variable, जो हमारा 1 0 0 था पहले इसमें फर्स्ट टेबल में, now when you divide by 3 it is no more 1 0 0. ये भी सब चेंज हो जाएगा when you do the next transformations. So we can cancel that A1 column. We need not continue with that artificial variables. Once it goes out of the basis, don't consider that for the future tables, future calculations. ठीक है? So when we divided this first row by the key element 3, A1, which was already there in the basis as 1 0 0, that has become 1 by 3 now, which means that this has gone out of the basis. Next table में A1 यहाँ पे नहीं आने वाला है. So we need not even do calculations also for this A1 column. Just cancel करो and write the remaining variables. ठीक है? तो ये वाला, ये तो ऑलरेडी 0 1 0, इसको हमको वैसे ही रखना पड़ेगा, खाली इसको हम चेंज कर, इसको हम कट कर सकते हैं. Now this is a key element. Make these 3 elements equal to 0. 4 को 0 करना है, 1 को 0 और this को 0 करना है. So row transformations will be R2 minus 4R1, R3 minus R1 and R4 plus 7M minus 4R1. First row will remain so writing all the variables. Now I am writing the variables without A1. ठीक है? A1 के बिना मैं लिख रही हूँ यहाँ पे, because A1 को हमने cancel कर दिया है. When you do the row transformation, all these numbers are not going to be 0 0 now. They're going to change. तो ये पूरा A1 का जो है हमने पहले ही, we are not going to use this column for the transformations also. पहले ही हमने cancel कर दिया है. Okay. Now first element same रहेगा, तो 1 1 by 3 0 0 0 and 1. Even if you write nothing wrong in that, but उतना calculation extra करना पड़ेगा. So it's better you remove that column in the next table. Okay, tell me the first row now. Second row, sorry. Tell me the second row. पहले तो 0 हो जाएगा, right? Second element 3 minus 4 by 3. R2 minus 4R1, 3 minus 4 by 3. माइनस 5/3 प्लस 5/3, ओके 5/3। उसके बाद थर्ड में क्या आएगा, -1 प्लस -4 इंटू 0 दैट इज -1, ये तो 0 ही हो जाएगा। 1 माइनस ये तो 1 रहेगा। 6 माइनस 4 दैट इज इक्वल टू 2। देन थर्ड रो में हमको क्या करना है, R1 माइनस R3 माइनस R1, 1 माइनस 1 0, 2 माइनस 1/3, 2 minus 1/3, 6 minus 1, that is 5/3, okay. Then 0 minus 0, that is 0, 1 minus, that is 1, 0 minus 0, again 1, 4 minus 1, that is 3. Then the last one, this will be 0. What is this value? -4m plus 1 plus 7m minus 4 into 1/3. थोड़ा बड़ा कैलकुलेशन है इसका, मतलब you have fraction, that is why. So it is -4m plus 1 plus 7m minus 4 into 1/3. -5m minus 1 whole thing divided by 3 है हर्ष, या फिर only 3 1 से divided है, पूरा divided है ना, okay. What about others? Just write in the paper -4m plus 1 plus 7m minus 4 into 1/3. Be careful in calculating because fractions हैं यहाँ पे. I also got -5/3m minus 1/3. चेक कर लो, R4 के बदले -4m plus 1 plus this into 1/3. Open the bracket, collect the coefficients of m and the constant, you will get this as the answer. Next में क्या आएगा, m, that is m ही रहेगा यहाँ पे. फिर next one 0, A2 में भी 0, there is nothing. -5m, 5 minus 5m/3 minus 1/3. Yes, correct. So again now XB column में, XB column, again you should see after applying the row transformation whether you are having a 3/3. If there were 3 constraints in the given problem, you should get 3/3 unit matrix at the end of each table. After using the transformation, you should get 3/3. So 1 0 0, 0 1 0 and 0 0 1. 1 0 0 corresponds to x1, 0 1 0 corresponds to A2, and 0 0 1 corresponds to S2. Then Zj minus Cj. So now we have only one negative number in Zj minus Cj. So the second column will become the key column. Ratios are taken only for the positive numbers in the key column. So divide this 1 upon 1/3. कितना हो जाएगा? 1 upon 1/3. Divide करना है ना, bi upon the corresponding positive elements in the key column. तो अगर मैंने 1 को 1/3 से डिवाइड किया तो क्या बचता है? It is only 3. फिर 2 को अगर 5/3, 2 को या 3/5 से मल्टीप्लाई किया तो I will get 6/5 and this will be 9/5. ठीक है? So which one is the key row now? Which is the key row? First row or second row or the third row? See, A1 हमेशा whenever A1 what is that? That A1 column is no more a part of unit matrix, you can cancel that. Don't carry forward this column in the next step. Whenever you see that in the previous first table we had 100 as A1, but when you divide by the key element 3, now A1 has become 1 by 3, which is no more 100 now. So we can cancel that A1 column. Even if you take carry forward, nothing wrong in that, but क्या होता है उतने कैलकुलेशन बढ़ जाएंगे ना हमारे. तो जैसे ही आर्टिफिशियल वेरिएबल मूव्स आउट ऑफ द बेसिस, यू कैन कैंसल दैट कॉलम. ठीक है. हमेशा in all begin method, whenever artificial variable is not there in the basis, just cancel that column. जब यहाँ पे 100 है तो हमको रखना है. जब तक यहाँ पे A1 आता है तो A1 को रखना है. जब यहाँ से A1 निकल जाता है तो A1 को हम छोड़ सकते हैं. Second row will become the key column because 6 by 5 is the minimum ratio. Okay, and the key element will become 5 by 3. Ratio is, we are taking the ratios of BIs upon the corresponding elements in the key column. यहाँ पे 3 elements थे, 1 by 3, 5 by 3 and 1 by 5 by 3. So 1 upon 1 by 3 is 3, 2 upon 5 by 3 is 6 by 5, and 3 upon 5 by 3 is 9 by 5. तीनों में से जो minimum है, that becomes the key row. तो यहाँ पे 6 by 5 is the minimum ratio. So that means it becomes the key row, and the key element is the intersection of key row and the key column. Swastik, what is your question? Ratio matlab, what do you want to know? Yes, this is applicable only for artificial variables. We can cancel that, not for slack or surplus. Why we are cancelling? Because हम लोग minus m cos दे रहे हैं ना वहाँ पे, तो बड़ा एक number ही पूरा अलग है वहाँ पे. So this is applicable only for the artificial variables. Okay, it is meant, it is only for the artificial variable, not for slack or surplus variable. Okay, Anjali. Yeah. तो अभी हमको क्या करना पड़ेगा? की एलिमेंट को 1 करना है, बाकी एलिमेंट्स को 0 करना है इन दिस पर्टिकुलर कॉलम. तो अगर इसको 1 करना है तो पूरे व्हाट यू से, पूरे रो को 5 by 3 से डिवाइड करना है. पूरे रो को 5 by 3 से डिवाइड करना है, एंड देन आई हैव रिटन द सेकंड वन. अगर मैंने 5 by 3 से डिवाइड किया तो आई हैव रिटन दिस एज द सेकंड. और जब मैंने 5 by 3 से डिवाइड किया तो ये हो जाता है 3 by 5. अगेन 3 by 5, अभी जो A2 में है 0 1 0 निकल के 0 3 by 5 0 हो गया. Just cancel that A2 column also. Okay, just cancel that A2 column also, because A2 is also no more 0 1 0. Cancel that also. तो नेक्स्ट स्टेप में हमको A2 भी नहीं लिखना है, खाली x1 x2 s1 s2 और bi's लिखने हैं हमको. Okay, so now use the row transformation, make these 3 elements 0 using this element 1. So it will be R1 minus 1 by 3 R2, R3 minus 5 by 3 R2, and R4 plus this into R2 hoga na. This is R2, not R1. This is R2. Let's change that. One second. Huh? This is R2. Second row will remain as it is. Second row will remain as it is. तो पहले variables लिखूंगी. Now we will not write artificial variable because that is no more in the basis. Now tell me what is the first row. R1 minus 1 by 3 R2. तो पहला तो 1 ही रहेगा. Second 0 हो जाएगा. Third क्या बचेगा? 0 minus 1 by 3 into minus 3 by 5. So 1 by 5, this is 0. And then 1 minus 1 by 3 into 6 by 5. That is the answer. BI में क्या आएगा? 1 minus 1/3. R1 में 1 आ जाएगा, R2 में 6/5 आ जाएगा, तो 1 minus 1/3 into 6/5. 1 minus 2/5, I think, no? 3/5. Is it okay? 3/5? ओके, थर्ड रो में R3 minus 5/3 R2. तो पहला 0, फिर 0, 1, 1, 3 minus 5/3 into 6/5. I got the answer as 1. Just check that answers. Or for the last column, 0, 0. Let's check what is this element. M plus 5/3 M plus 1/3 into minus 3/5. This is a lengthy problem because two artificial variables were there. जब तक आर्टिफिशियल वेरिएबल होता है तब तक m आता ही जाएगा. एक बार आर्टिफिशियल वेरिएबल निकल गया ना, then you will not get. Now this is also cancelled. So in this step you will not get any m. Once it moves out of the basis, then you will not get that m wala term. It is normal as the previous simplex method only. So what is this element? M plus 5/3 M plus 1/3 into minus 3/5. I got the answer as minus 1/5. Let's check that. M plus 1 आ रहा है कैसे? M तो आएगा ही नहीं वहां पे. M part has to get cancelled. यहाँ पे m आएगा नहीं बिकॉज R4 के बदले m पुट करेंगे और फिर इसको -3/5 से अगर मल्टीप्लाई करेंगे तो ये -m हो जाएगा. m and -m will get cancelled. Once this artificial variable goes out of the basis, you should not get m also there. Harsh, please check your answer. -1/5. Yes. ठीक है, फिर XB कॉलम में रहेंगे x1, x2 and s2. Sj minus Cj. Still we have one negative number. So again this is the key column using the ratio. ठीक है, फिर से now we have to take the ratios of this upon this. But again second one is negative, so we cannot take this as the for the ratio. Only first and third column ratios are to be taken. So 3, second one, and third one is 1. This is the key rule. And this will become the key element. So this is the key element. Abhi, it's already equal to 1. ये अभी तीनों को, next step you will get the answer. In the final step you will get the answer. Use the row transformation. R1 minus 1/5 R3, R2 plus 3/5 R3, and R4 plus 1/5 R3. In the next step, you will get the answer. So third row will remain as it is. The remaining rows are to be simplified. In the next, I have not given the animation. I just have the final table only with me. You just calculate, use this row transformation and tell me what is the first row. We can check the first row then. Okay, I've got the answer. I'll show you the answer. I've got this as a final table. Just check your answers. Next table, you have got all Zj minus Cs positive or negative, positive or zero, and we have the final solution here. Okay, you can try this part and tell me the answers are right or not, the calculation part. Only these two numbers are to be checked. बाकी तो सब 0 1 0 0 ही हो जाए, खाली ये दो ही हमको चेक करना है. And then we have to write the final answer. X1 is equal to 2 by 5, X2 is equal to 9 by 5, and then Z is equal to 17 by 5. So this I am calculating Z from the given, not with the minus maximizing wale function mein. Directly I am substituting in the minimize Z function. Correct hai na values? Okay. There's one more question with a similar type. The answer is 6 by 5, 3 by 5, and something like that. That was asked in the exam, not the same question, I think, but similar type of question where we have one equality, one greater than or equal to, and one less than or equal to constraint. Okay. So hope you're clear with this big M method. In the next lecture, we'll start with the next topic, duality. So thank you for today. If you have any doubt, you can ask. Otherwise, we can stop. Write your attendance in the chat box. I'm considering only those attendance in the chat box now. Don't forget to write the attendance. I will share this PPT in the Google Classroom. Plus notes also I will upload with more number of problems.
Ma'am, in last part you have taken Z equal to 4x1 plus x2, ma'am. But we should take maximization, ना ma'am? आपने तो minimization ले लिया.
Question क्या था? Minimization question था ना हमारा?
हाँ.
हमने solve करने के लिए उसको maximize से convert किया.
Question हमारे बाद में फिर को
इसलिए मैंने बोला माइनस अगर लिया भी ना तो फिर माइनस मैक्सिमाइजेशन ऑफ माइनस जेड पुट करना पड़ेगा उसकी वैल्यू, तो सेम आंसर आ जाएगा वो. ठीक है, तो इसलिए मैं क्या करती हूँ, माइनस को मैक्सिमाइजेशन ऑफ माइनस जेड उसको लेके सॉल्व करती हूँ और बाद जो गिवन जो प्रॉब्लम में था उसमें जेड निकाल देती हूँ. तो कंफ्यूजन नहीं रहेगा वहां पे.
ओके मैम, थैंक यू. ओके.
कुंभोजकर F4, I'm not having the PDF of that. स्कैन मेरे पास नया कॉपी भी नहीं आया अभी तक. I'll try. If I'm getting it, I'll upload. I'll see. मेरे पास कॉपी नहीं है, पुराना है मेरे पास. I'll try to